All right. Wait, not anymore. Ah, come on here. There we go. All right. So, good evening, afternoon, night, everyone, and welcome. I have a very enigmatic title, and if it doesn't ring any bell to you, you will very soon learn about it. If you know what it is about already, I am not sure you will learn a ton, but we're going to talk about architecturing Elixir applications. So that's the guideline of this talk. And if you're like me, the answer to that question would have been, well, most of the time I'm doing a web application. So I'm starting up a Phoenix app and I'm just following the conventions that I've seen around, like in tutorials, in courses, or in the web. The problem is, that's a problem. What if it's what you're building is not just a web application? I've worked on software that is not necessarily only exposed to the web. Maybe the same features are exposed to an API, a CLI, an SDK, other kind of mediums. And my main question is, what if it grows big? Like, what if you're doing Elixir in production? That's your main code base, and it will grow big. In my experience, and it's not just my experience, many people are asking the question, how do you organize your code? Where do you put the files? Like, do you have any best practice? Because Phoenix doesn't, as far as I know, forces you to, like, they don't give you strict guidelines about how to organize your code base. And so many people have many questions and many opinions about this. If we're talking about another language, there are a bunch of software architectures out there. I've picked a few. The more classical one will be a classic layered architecture that everyone learned probably when they got into programming. But basically, model view controllers, and then you split your files between 3 folders like that, and maybe eventually you add layers. Which layers depend on your conventions and what you adopt, but that's a standard way people are organizing their code. There is another one that I really love in other languages. I use hexagonal architecture, which may, it's really simpler than it sounds. The core of it is to really separate the pure logic, the domain, the functional core, from everything that is called infrastructure, and infrastructure not as in DevOps, Docker, and machines and all, but in everything that interacts with the outside world, which you need because your software doesn't run in a vacuum. So you need to connect to a database, you need to talk to third parties, you need to expose your software via an HTTP API or on the web, etc. So you need to connect to the outside world, but making the separation between the pure logic versus this outside world, and having the outside world part of your code depend on the logic and not the reverse, is what hexagonal architecture is about. And there are many, actually, I've found many other architectures that have different names, different nuances, like the onion architecture, the clean architecture, the A-frame architecture. There are many architectures out there with different names and shapes, but they tend to share that common attributes, like, okay, separate the pure logic from the rest and make the rest depend on the pure logic, and not your pure logic depends on your infrastructure, IO, outside world, whatever you name that. The presentation tonight is based on a book. Yes, Nurul, if you have a question, go ahead.
I saw a question. I think, is it similar to domain-driven development, like DDD?
It is connected.
Okay,
it is connected to domain-driven design, DDD. It is not similar, because domain-driven design will focus on, okay, your domain code, like forget about the infrastructure, but your domain code, how do you organize it? And they come mostly for object-oriented software, they come with entities, aggregates, like a bunch of things. They also focus on the vocabulary, the language you use. That's very important in DDD. And that's what it is. It's about, okay, your domain, how do you grow it together with the team? It's compatible with these, but it won't tell you if you can apply DDD with a layered architecture if you have a domain layer, or with all of these architectures, as long as you have an isolated domain. Did someone else raise their hand?
Oh no, it was me by mistake.
Okay, sorry. Okay. All good? Right. So the presentation tonight is based on a book I read recently, a little bit by accident, actually. It's from 2019. It's called Designing Elixir Systems with OTP. And I was not expecting that this book was actually presenting you one way to structure an Elixir application, and in a way that it can grow. And so the key sentence to remember, and you can see that on the cover, is do fun things with big, loud worker bees. That's easy for your brain to remember, and that will be a way for you to remember the different layers of this architecture. So that's the name of the talk, if you paid attention, and this is where it's coming from. Diving right into it, it looks like that. So good stuff here. You have the big picture of what it looks like. So all of the words correspond to a different layer, and in practice, it's a little bit more nuanced than this. We're gonna see that very soon. But in short, you have the data part, for do, the functional core for fun. So I did all of this introduction about separating the functional core from the rest. It's the same here. We have the functional core, and we will see that actually the data is also part of this. Things are for tests. So test, they put that on the side mostly so you don't forget about test, and to say that you're going to test your functional core, of course, but also the rest. And the rest is the boundaries. So all things about gen servers and processes. The life cycles, so the supervisors of your application, that part is going to be actually simple. And eventually the workers. So let's dive into this. First part, the data structure. This is actually part, we're going to see the code soon, but it's actually part of the functional core. But the idea here, the suggestion is to start thinking about your domain in terms of how do you represent the data? Because there are many ways to do it. So first requirement for you is to know the available data types in Elixir, especially if you're not yet very familiar with the language. The documentation is really good. Spend some time getting familiar with that. In my experience with growing application, we tend to use a lot of structs, maps also, but yeah, structs are like they often become needed. An example from the book that shows that you could, for the same problem, you can use different data types, and that will have an impact on your design. Let's say we're building a tic-tac-toe game, and we want to represent the board. So there are different ways to represent that. Let's say we go with this. And so it's nice because like you write in the code, and very visually you can see the board, right? So there are two things you want to do with this board. You want to be able to read something. So for example, let's read that element. So we can use the lm function to first get this row, and then to get this cell here. And this will return what we want. And it's kind of easy to do so. Now, if we want to update and say put a new token here, well, new token, I mean an O token here, that is more involved. And that's because Elixir is a functional language with immutable data, which means that if you want to mutate that table, that board, you actually need to create a new one where you will replace the middle row with the new one, where you will replace that first element. So that's what we're doing here. We first craft our new middle row by accessing the existing one and updating the element, so that returns a new middle row. That is what we want. And we use that to update the board with the same logic. So we put the LM on the board, and that's it. So that's one way to do it. Let's do a little tweak and go with lists. So a nested list of strings to represent the board. Really, the symbol is very similar. It's just another decision. But by changing that data structure, you unlock different APIs to deal with your data. So to read the same element, we have other functions. We can use get in. So get in this board, which is a list. And we can provide a list of indexes, if you want, with the access API. So here we're going to say, well, we want the index 1, and then when you're here, index 1 again, and that and that will return the X. The good part is for the update, because the syntax is almost the same. So it's very coherent here, because you can use put in. You will have the same pattern here to access your element, and then you provide the element you do. So see, just by using a list here, we have a different way, maybe a more intuitive way to access our data. Another way, and that actually concludes into a recommendation, another way to represent this data will be to go with a flatter structure. So deeply nested elements are always annoying to deal with when data is immutable, because, well, you need to update that thing and then to propagate your update to the bigger data structure. So in general, you will have an easier life if your data structure is flatter. A way to make it flatter is to use a map. And for the keys, you will have the coordinates. So it's the same. You have 0, 0, 0, 1, 0, 2. It's just a different way of representing the same data, the same information. Now, to access something is very trivial, because you would provide the coordinates of that element. And to mutate it is also going to be trivial. You can use map put to mutate that map. You provide the coordinates, you provide the elements. So see, same problem, but thinking about the data structure, and depending on what you choose, it will make your life easier or harder. My recommendation here, and it's also from the book, is to experiment. Like, doesn't mean you need to get it right first. In general, flatter is easier. And the thing to look for is how many workarounds you have to do, like how easy it is to access the elements and to update the elements. And if you feel, okay, it's starting to be a bit hacky or very verbose, maybe think about, like, go back to the whiteboard and could you represent that data structure differently? Neural, you had a question.
Yeah. Could you also use a flattened list?
Yes, you probably can use a flattened list too.
Like, let's say from 0 to 9 index. And
yes.
Maybe up to
and you could like it will work. And again, it will depend on what do you want to do. So
right.
Probably go with like, if that works for your use cases and it's simpler, yeah, I'm like, go for it. And the moment you see, oh, now I want to implement that feature and it's hard because of the way the data is structured, is a moment to pause and think, oh, can I refactor that data structure into something else and then get a bit more complex? It's a good way of doing that. Okay, and finally, functions are data too in Elixir. So you know it probably, but you can pass functions as parameters. That's also something that I never used that, but imagine you have an application with processes that need to scale and you have a lot of data to send from a process to another. but the data could be derived from a function. Providing the function to the other process as an argument may be a faster way of doing that rather than sending the data, because sometimes it's simpler to just send minimal data and a function to compute rather than a big amount of data. Functions will be sent across processes just fine. And finally, we're going to revisit that a bit later, but if you're used to use Phoenix and Ecto, you may tend to jump into defining your Ecto schema first, like the database first, which is often fine, but it's a missed opportunity, because when you do that, you usually tie everything else, like down to the API, you tie all of this to your database schema. And by thinking about your problem first without thinking about Ecto and persistence, like just representing your data model in pure code, and then you will think about, okay, how will I store that in the database? And maybe it's very similar and it's going to be a simple mapping, or maybe not. But that gives you more flexibility, especially since we want to move to the function part, which is the fun part. So that's the core of your application. If you modeled your data without Ecto, now you can start writing some pure functions that do not depend on the database. So where do you put that? First, the data. In the book, they have an example. We're building a quiz application from the beginning to the end. So where we cover all of these layers. They call it mastery. And we have so we start with the core data structure. So it's going to be a quiz. So there will be responses to that quiz. It's a simple struct. Well, it's a simple struct. It's a struct. But yeah, it has a couple of fields: quiz title, the answer, the email of the person who answered, the timestamp, whether it's correct or not, etc. So they represent that with a struct, right? Note that this is not typed. If you like typed struct, I recommend to check out that library called TypeStruct. It's really nice. But so you define your data here, right? It's a response. Where do you put the logic? Well, actually next to it. And so that's why I told you at the beginning you have the data and the function layer, but they actually belong to the same. It's just that think about the data structure you're going to use, but put the functions that manipulate this data structure next to them. So they're going to be in the same file. And at this point, it's just pure logic. So for example, here we have that's a simple one, the response model. We just have a function that will create a new struct based on an existing quiz, an email, and answer, and then we do a bit of work to create the struct that we need to use. For example, the timestamp will be now, which is interesting. Also, we could consider this will be depending on the system, but never mind. So something more involved. So the actual quiz is more involved than the response. And you can see it's the same logic. We have our quiz structure, so what the data looks like. And next to it, we put all of the functions that's going to manipulate this data structure. It's like, if you're familiar with object-oriented programming, it's going to look a bit similar to what a class would do. The main difference will be in a class, you would hide the data and you will just expose the behavior. Here, it's a functional language. So everything is transparent. The data is exposed, but it's not mutable. And you put next to it all of the pure functions that will usually here take a quiz and return a new one, a modified quiz. So we do not mutate the same reference, but we return an updated quiz. For example, select question, we pass it a quiz, and it will return you a quiz with a question selected. There is no other argument, so I guess it's based on attributes that are already on the quiz. Okay. So put the functions close to the data that are dealing with. At this point, there is no notion of gen server, no process. If you feel that you need one, you need to think about the design, because it's not supposed to be at this point. At this point, you're just coding the core logic of the feature you're building. So here in the book, we're building the whole, hey, we can create a new quiz, add a template to it, we can pick a question, we can remove a template from a category. There are a bunch of actions that we need to do, and it's just pure logic that we do. And this we can test. And then we're going to need to integrate that with the outside world. And at this point, we're going to talk about the test, but you can play around with your API using the REPL. One advice that I found was really good was to use functions to name concepts, regardless of how many lines it takes. Sometimes you may have like a single line that you extract to give it a name. The idea here is not to extract everything, because extracting creates an indirection, which has a cost. No, you need to read something else to understand how it's made. So don't do it too much. But you want to be at the same level of abstraction. We're going to see that later in the presentation. But when you have a mix of levels of abstractions, it's a bit harder to follow the code. And if you can have like high-level code, and then when you dig into it, you have low-level code, it's better when it's consistent, at least for your brain to think about it. And yeah, in Elixir, we pipe functions a lot. It's a functional language. Sometimes it's fine. The functions, they do pipe naturally. Like you have a function that takes a quiz, returns you a quiz, so you can pipe another function that takes a quiz. Sometimes they do not compose like this. So to do that, you can use with. We're going to see it later, but with helps you compose functions that have different signatures. And another advice they are giving, and I think was really good, there is a link to a presentation that was made about this, is to use tokens. So a token is really something like the ecto change state or plug con that you may be familiar with, like the connection. It's a struct that you pass around, and you make all of your function accept this struct. So in general, your function do not need all of that struct, but they will be able to interact with it, to modify it, and return that same struct. So it's a way to standardize your function signature so you can connect them together. And this is based on the struct that you create that will make sense. Of course, it's like, do not start with that. But if you're struggling connecting functions together, it's one nice way of doing it. The code looks like this at this point. So you have a project. We have the lib folder where the source code is. And here we have our applications. We may have many applications. We're going to see this top-level file later. We have a folder with the detail of your application. And inside, they recommend you to create a core folder. Well, they show you to create a core folder. In my experience, that's totally fine. But if your application grows and you start having a lot of files in this core folder, it means you probably need to split into smaller chunks. You need to extract, like there are things that can be grouped together, and they should have their own named folder with their own core folder. So you can, again, see what this is about. And the danger is to have, this is not the case, but the danger is to have a big like views folder with all of the views of your application inside, and you have 50 of them. And it's a bit annoying to navigate, and especially when you need to change a feature, or like to implement a feature or to fix a bug or to change the code. If you have to go through 5 different files that are very far from each other, it means your design is not cohesive that much, which can be an issue because you may remember to update these 5 files together, but someone else may forget about one because they do not know that this file that is far away is actually related to this file. because we tend to split code into technical layers. And here, this is what we are doing with core. Core is purely technical, but at a small scale like this, it's totally fine. So start with this, and then as it grows, try to just organically recreate boundaries around your model. So here we have our data and functions together. We're going to talk about tests. Quickly, I just want to mention that they talk about tests as like it's a third layer. It is not. Yeah, just to say, it is not another layer. And they say it in the book. They were just like, okay, in practice, you're writing tests as you're developing your functions. In the book, we do the data, then we do the functions, then we do the test. But in practice, you don't get all of your functions at first. Actually, in practice, you probably go through all the layers and you do back and forth to iterate. But we're going to address the test part now. Nurul, you had a question.
Yes, if you go back to the previous slide where you were explaining the architecture. Yeah. So when do we, so let's say I have a particular, let's say validator that I created, a custom validator. And I am using it in the, let's say, chain set, like the, the actor chain set. So
Yes.
where do I put that? Do I put that inside the live folder, or do I put that inside the mastery folder?
We're gonna see that it's the fourth layer. It's the boundaries.
Oh, okay. Yeah. Understood. Okay.
We are getting to that part. Yes.
Okay.
Especially the validation example it's a good one because it typically belongs to the boundaries. Like imagine here at this point, this is just a happy place where everything is perfect and you're not connected to the outside world. It's just so it's not very useful at this point because it's not exposed. But we're gonna get to this part just before the test. So yeah, write the test as you go. I would suggest at this point, especially for the functional core, you may give TDD a try. And if you do that, I suggest you use, there is a dependency called mix test watch. Very handy because you can run that command and it will keep watching for your changes and rerun your test automatically. So you have a faster feedback loop. In my experience, especially with the functional core, like if you code with this architecture, like thinking about how can I extract pure logic that I will then use in the rest of my application, it creates you bubbles where it's very easy to code, have fast feedback, and you will have faster feedback with your tests than you would have by manually playing around your API, especially as it grows. At first, maybe not, but very quickly, you will have a much faster way to try new things, new scenarios. And we're gonna here. I'm just gonna talk about investing a little bit of time to make your life easier when you write tests. So first, fixtures. We do that in the book. We actually are using a macro to do it, which is fine. Like so, you have the example here. You define a macro quiz builders that you will use in any of your tests. And that macro is doing two things. First, it automatically aliases a bunch of helpful names, so you can just use them directly without having to alias in all of your tests. And it exposes a couple of useful functions, for example, to create a quiz, because the quiz data structure is kind of involved. It's not a trivial one. And so building one in every new test actually can be very noisy and very annoying to do. So you do it once with a builder, and then you can just reuse it everywhere. Now, personally, I'm not a super fan of that because I don't like that when I write a test and I call this, I don't really know what it gives me or not. And the tooling around it, in my opinion, is not great yet. So I think there are other ways of doing that, but it's one way. If you don't mind, because it's your project and you're a small team and you're familiar with it, you will be super productive. My problem is when you come to teams where like people come and go, etc. The discoverability of this is much harder. It's something you need to learn about the application that is custom. I much prefer things that are very explicit, but it doesn't have to be very verbose. We're going to see that. All right, so we have the fixtures, but we also have setup functions. So it's very likely that your test will try different scenarios, different variants and tweaks of the same logic, and you are just going to tweak one or two things. And so instead of repeating yourself in all of your tests, you can use setup functions to provide you with like a context that is already set, and so it's less noise in the test, and you can just go ahead. So here is an example where we define private functions. So this is a right answer, and by the way, the context here is a token. So like everyone gets a context struct, and you can do whatever you want and return that as a response. Here we use Elixir to call these in the setup, and here we retrieve our context. So these functions will be called, and here we will have access in our context to the right answer, that is response 3, and the wrong one, that is response 4. And so we can do assertions, we can do more stuff here, but basically we have abstracted away the creation of these so we can reuse them around. I would give another warning here when you do that. There is a coupling, so it's not a reference coupling, because again, data is immutable, so there is no chance that this mutates into something that will make another test break, like it will be in an object-oriented language. But it's a functional coupling, if you will. All of the tests will have the same setup values. So if for one test you want to change the value, and that happens in my experience, you may break other tests that were actually depending on different defaults. So be careful of that. And I would recommend another way of doing it, which is very similar. Like I still abstract away the logic to create my data that I need for my test. So I have only one line to call. But I do call that line first thing in my test. So it's really isolated from the rest. And the bonus is I can provide parameters. So sure, there are defaults, they are handy for, especially for the things that I'm not really testing, but they are needed for the struct to be complete and valid, especially if you're using typed struct. But I want to provide the values that are interesting in the context of this test. So here, it's much more explicit that 3 is the right answer because we're adding 1 and 2, and 4 is incorrect. And I can tweak these and do whatever is relevant for the test without worrying about breaking another test. Still, the details of building a quiz and the responses is abstracted away. And to me, that is the investment that is worth. Because it's very easy for me to write another test and I don't end up with 2,000 lines of test because I have the same struct duplicated across 20 tests. So in short, write your test and then extract the noise into functions that you can call. So you give them nice names, you provide parameters for the values that are relevant, and you remove the noise from the test. Assertions, so that's another example from the book, but yeah, it's also interesting to create custom assertions, especially when the tests are more complicated. Sometimes you're testing things that are a bit more like involved, and so creating a function, naming it assert blah 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 is it's a nice way to make your test more readable and also to reuse that. Here I use that example because you can. I really like that you can follow this test, and it's a pipeline, and we're doing assertions along the way. And that assertion, if you look into it, so it's a simple refute is nil quiz, but it's much easier to read assert more questions, so we understand there are more questions, rather than knowing that no more questions will be the case when the quiz is nil. that is more of an implementation detail at this point. So we have the same level of abstraction here, and you can see with the colors. Here is more low level. And we return the quiz, so that's the interesting part. We return the quiz also so we can chain and pipe. We don't have to. This is more a high-level use case that we're testing. Here we're testing the quiz. So it's, remember, in this application, it's really the top-level thing with a lot of functions that are manipulating lower-level functions and concepts. So you can have purely functional test here with no database involved, and yet here we're doing a lot of, like, we're selecting questions, providing answers, correct answer, wrong answers, and really trying scenarios that will happen in our real application without having to deal with any database, any third party, etc., just because we focused first on the functional part. All right, we're gonna exit the happy place now, and we need to integrate with the real world because at some point that needs to be exposed in a web application or in whatever thing to the outside world. This is what they call the boundaries because it's the boundary of your application. It's really like the infrastructural layer. If you go with hexagonal architecture, for instance, it's everything that integrates with the outside world and that will use everything you have built before. Again, in practice, you actually go back and forth. You probably may start with this, like try something and prototype something here, but then quickly the idea is to step out, to extract what you started to build now that you have a better idea, and play in your functional playground, and then use that to later, okay, do a check test with the boundaries to see if things connect together correctly. So from the book, a couple of ideas of when to create a boundary. In general, whenever there is a process involved, this is a boundary. If you want a gen server, it's a boundary. So everything that touches the I/O, everything that touches the external world will be in the boundary. Here, the structure of the code. So the boundary, there are two parts actually. The first one is this top-level file. It is the top-level API that other things are going to use. And when I say other things, it could be other applications in your project. But it's going to be Phoenix, for instance. You're going to expose your behavior to be used in Phoenix code, for example, and you will use that top-level API. The nice thing with this, it gives you a chance to have, again, a higher level of abstraction using everything that is below. And so it's a nice separation. You can do a lot of changes here without having to touch this part, or you can maintain backward compatibility, because here means you're publicly exposing that. So again, it depends. If you have no client, no user, only one, you don't need to go fancy. But sometimes it grows and you need to have that decoupling. And so we would create a boundary folder just to separate from the core. And this is where we will put everything related to a process. So there are going to be gen servers. And the validation that you mentioned a little earlier will also be here. Let's see the code. So that's the top-level mastery file. See, and that's our module. It's mastery. So anything that wants to interact with our quiz application, we'll call mastery dot, and there we have our API. So our API will be, we can build a quiz, we can add a template, we can take a quiz. This is a concept that was not explicit in the lower level. Taking a quiz involves more than just creating a quiz. Selecting question that is just delegating to something else. So sometimes you don't need to do fancy stuff. You just delegate to a lower level. We can answer a question. Notice here, we're going to see that, but we have a quiz manager, and it's coming from the boundary. And we have a persistence function that is actually coming here from the environments. But the persistence, and so ecto, will be passed here. And there are schedule, like we're going to see the scheduling later, but this thing depends on the boundary modules. Like it can import everything. Having a core and boundary folder helps you with that. In the core folder, you should never have an alias mastery.boundary. Like you should never have a .boundary alias in the core. In the other folders, it's totally fine, but in this folder, you should not in the core. Okay, if we take an example, adding a template, what it looks like in terms of the function calls. Something is going to call add template on mastery. Mastery will do validation of data. Usually the validation you do at the boundary, because it's the data coming in, and at the very bottom here, you have your happy place that expects everything to be happy. So you want to verify here and not have to verify later, because this is just one function, but you would imagine that here we will actually call and combine 5 different smaller functions to implement our behavior. That just didn't fit in that slide, but that's what will happen most of the time. So you don't want to validate everywhere in your core. So you do the validation here, especially that this may come from the outside, like from the network, from the API call, from the database, from whatever. So you want to check here that things look legit according to your validation rules. Then the top level API is not responsible for doing the actual work, so it delegates to something in the boundary that will take care of it. So in general, it's the gen server. So here it's going to be to add the template. It's going to be the quiz manager that is responsible of managing quizzes. It's under the hood. So it will expose an API, but under the hood, it's going to send a message to the server, and then there is a handle call that will text the message and deal with it. And the logic of dealing with whatever data we have will be delegated to the core. So you will reuse whatever pure logic you implemented to make your feature work. And so the good thing here is you only have to deal with the messaging and scaling and everything that is relevant to a process, but you don't have if, else, and all of that kind of branches to test here. You can test it here directly without having to involve processes. And then it answers. On an architectural perspective, it looks like this. So we have the top-level API that delegates to gen servers. So we have the quiz manager that I presented before. We also have a session manager. So the people taking the quizzes. So we have something that manages the quizzes in itself, but then a quiz could be taken in a session by many users. Imagine a class of students, 30 students, and they are taking one quiz as an exam. And so you have, we have different sessions at the same time of that quiz instance. In any case, so that's your structure. The gen servers will delegate the work to the core logic that you have built. And the core doesn't know about the fact that it's used by a process or whatever. How do you put that? Yes, Norul.
So if you go back to the previous slide, so all of the dependencies and everything are basically going to be in the mastery API part.
Most of it, yeah, they could be also here.
Okay, and the core will basically try to keep it as clean as possible, basically taking in, let's say, quiz structure without any errors or like, but I mean, when we are working with core, we are expecting it to receive a quiz, which is basically clean and is correct.
Yes, yes. And for example, if you want to do a call to the database to get some data to do the logic, you would do you would do it here and pass the data to the core function.
Okay.
That's one way. Another way of doing it, you could also decide that the core function takes a function as a parameter, because you can do that, and that function will be provided here to actually retrieve the data. But so the core is calling a function itself to get the data without knowing how it's implemented. So
Like with the callback function, you mean?
yeah, a callback function, exactly. That's another way of doing it. But I think the simpler way is just to split your, so if you have something you need to do with the outside world, you split your call logic. So you have a function before, then you do your call, and then you plug it with a function that deals with that data later after and returns you whatever response you need. So here, it just becomes a game of plugging things together. You have all of your Lego pieces from the core, and that you connect with wherever you get your data from, or APIs you talk to, or whatever. And so it connects to this. How do you integrate with the Phoenix application, for instance? Well, the part to look for are, you need to find the parts where you start a process. In Phoenix, it's going to be mount, for instance, and the part that deals with the callback. So it's basically the gen server. You need to identify where do the process starts for the init data and all, and you need to identify where do you handle the messages. And this is where you would call your core functions. In short, it means that, but I haven't tried it personally, so. And in the book, they just mentioned it, but they didn't show it. So I haven't experimented that. But in my understanding, the Phoenix code is either in the boundary folder, like you will have your live view in the boundary folder, or it's another application in your maybe umbrella project, and that is using your, like, say, master application. And that whole Phoenix application, it's a pure web app. It's all boundaries. So you just structure it like you would a regular Phoenix application. It's just that you have extracted away everything that was actually doing more. I have an example. I put up another example here. Yeah, no problem, Daniel. See you around. So this is an example of a live view, what it would look like. So it's a Phoenix live view. We have the mount function. So this is where the data is initiated. We have a handle event, and the role of the live view is to render something to the client. So this is very specific to Phoenix. It should not be in your core, right? But if you look into it, we are calling thermostat, which is our application. It's like mastery, for instance. So we are calling our top level API here, and we provide the values that we got from Phoenix stuff. So this is from the connection. We got the user ID, and that is coming from the route, from the path, I mean. So we got these, and then we call our function top level, and when we get the answer, we update the socket. But we do not pass the socket in our application, because our application could be used here, but it could also be used in something that is not a Phoenix live view. It could be reused in a CLI, or it could be like any other medium of exposing your application will be implemented. And it makes the Phoenix code shorter. Its role is to render something, bind events, like user events, to handlers. And again, here, we just delegate the work to our other application that is dealing with the thermostat. And then when we get the updated values, we deal with the socket. So here we manage the sockets, and we render things, and we bind together. But everything that is about how things are made, it lives in our other application somewhere else. And in this case, it's probably just pure core. It's like just a library. Imagine it like a library, pure logic, but it could be more involved. All right, so this I put a few tips that I found useful from the book, although not necessarily not necessarily relevant here, but I put them here if you want to read. Okay, so we have our processes. There are two missing concepts that are actually smaller. The first one is the life cycle. The life cycle is specific to Elixir. We're dealing with the Nectar pattern language. And so there is a question, how do you start and stop your processes? Often people will think about the supervisors as a way to recover from failure, but I think it's more of a byproduct. It's an effect of something else. So in this application, for example, we usually have a top level supervisor. And if you're using Phoenix, you actually, they have one for you first, but then you have your top level supervisor that manages your application, right? And then think about, okay, you have these processes. How do you start and stop them? In our case, the quiz manager, well, it's a regular process that we want to start and it will live forever. So we need one, and that's going to be a classic supervisor. For the sessions, and the use case is interesting here, it's actually more dynamic because a session will be responsible of handling one person taking a quiz, a specific quiz session, and we will have 30% at the same time on the same quiz, but they will all have their independent session. And we want to do that because we think, okay, if things go wrong and someone crashes, it doesn't take down everything with it. We just want one person to crash, and then it will eventually restart. So to have a one process per user, we need a registry that will take care of knowing, okay, who is on which process, and we're going to use dynamic supervisor. When the application starts and you observe it, you can see it follows what I showed you before. So we have a top-level supervisor, one for the quiz manager, we have the process, we have the quiz session registry, and we have independent individual sessions. So I had the sessions going on. Someone wants to join. Let me just let them in. All right. Yes. Hi, Nicholas.
Hi. Thank you.
All right. So it looks like that. Supervisors are about, like, the main question is, how do you want to start your processes? How do you want to stop them? When you answer these questions, it will do the scaling and the recovery for you. The strategy will be here. The lifecycle part is really the application file of your code. And you also, of course, declare that at the top level, because at the top level, you need something to start. Mix will start your top level supervisor that will be responsible of starting your processes that will be doing the work. In code, it's really simple because it's really just configuration. It looks like that. It's like in the book, we go with like building our own links between processes and all to experiment and understand how it works. In practice, you just lean on OTP. They do it for you. So you just declare what you want to do. Most of the time, you are declaring your process, you give it a name, and that's it. It's like, it's a regular process. It will start, and then if it crashes, it will try to restart without taking down anything else. And if it really cannot restart, it will bubble up the failure. For our dynamic supervisors, so we have a dynamic supervisor. We give it a name. We give it a strategy. There are different strategies for, okay, if one goes down, what do you want? Do you want to take only one down, or do you want to take everything down together? In general, the default is what you want. Sometimes it makes sense to take down everything because you need to start everything. So up to you. And the registry, we want the key. Do you want the keys to be unique or not? So like, you can read the docs. In general, this part, you don't spend that much time on it because everything is already provided to you. But it's still part of your architecture and what makes Elixir applications scalable and resilient. That was the lifecycle part, so very short, actually. The last part of the architecture is about worker bees. So what are workers in this situation? So it's a little bit on the side, meaning that it's not really something that is fully part of your application, but it still is. What I mean by that is it's a bit different from the lifecycle. The lifecycle, so it's the supervisors, they know how to start and stop your processes. It's configuration. The workers, they manage the concurrency of your application. So think about, of course, you have a cron job, for instance. So it's something technically outside of your application, but that will need to start and stop your processes at some point. Or something that will react to a request and start and stop processes or scale processes later. You may not need that. There are applications that absolutely do not need that. And if you have a Phoenix application, for example, and you just have that, they are doing it for you. You probably don't. But the moment you have like a cron job or a scheduler or something like that, it will be here. And it's good to separate that from the rest, at least conceptually. Technically, it's part of the boundary. Technically, there are really two layers. The functional core, that is like the data and the functions. And then you have the like the boundaries, but I would put the lifecycle and the workers in the same vein, in the sense that they know about your application. They just do not have the same responsibility. And it's nice to give a name to split the distinct responsibilities. You don't have so many, but you have these, at least in Elixir. So in practice here, it's going to be a Gen server, because it's something that stays alive and that needs to start and stop other processes. So it's going to be defined in you will have a supervisor for it, because it's a process. So you always have a lifecycle for it too. And it's going to be declared at the top level, of course. So going back to the supervisors, we add a new line. So yeah, Proctor, just in case because at first I thought it was a library. It's not. It's just because we're talking about quizzes and exam, and the Proctor is the person who will be like, okay, imagine the students are taking the exam, so that will be under the Proctor responsibility to start and stop the exam. So that's why they name it like that. But it's nothing specific. It's just a name. So we declare it here. It's a regular process. We don't need to do anything more. And if we go to the top level again is everything that is going to be exposed and so used by the outside world. So we had a function schedule quiz. To schedule a quiz is the responsibility of the proctor. So that worker is responsible of creating quizzes and stopping them. And we note that we have our validation here. And yeah, so it looks like this. It's a regular Gen server, so you have handle call functions inside, or handle info. And here, so we have a schedule quiz, and we have an end quiz. So schedule quiz will take the current time, or order the quizzes, get the quizzes that needs to be started, sort them, and then so to start a quiz, we log stuff, we delegate to the quiz manager, so it's another process that is doing it. And interestingly here, we schedule a message for later. In this case, we calculate when the quiz should end, and we send a message with that timeout. So at some point, we will get here. We will end the quiz, and when we do that, well, again, we delegate the work to the quiz manager and the quiz sessions to stop everything. Like quiz session is also a process, so each individual quiz session will stop that quiz, and then we respond. I am not so happy. So this is from the book. I am not, again, super happy with this. I would argue that, in my opinion, this is not the same level of abstraction everywhere, or rather, like this. I'm not happy here because, like, the end quiz is nice. We delegate to the quiz manager, we delegate to the quiz session, and that's it. Here, we do almost that, but we're sorting stuff and we're building quiz and then calling something, another method from quiz manager to build our quiz properly. In my opinion, this should be in the quiz manager. The only thing that really should be here is the fact that we send a message to ourselves later to end the quiz. That's the responsibility of the proctor. But the rest should actually be delegated to the quiz manager. So an updated version of that code would look like this. It's the same end quiz, but for the schedule quiz, we delegate that to a quiz manager that has a start quizzes function, because I mean it's a process that knows about the quizzes, so it can do it. We provided the current time. Okay, cool. Now, of course, for each quiz that starts, we need to send that message. So how do we do that? Well, again, it's my responsibility, but I want to delegate. So my way to solve this is to provide a callback function that we mentioned earlier. So I provide a callback function that will execute for every quiz that starts. And so for every quiz that starts, I keep the logic that was before, logging eventually, and then computing, okay, when does the quiz ends, and send my message. And so this is only responsible of delegating the work and scheduling the end. So yeah, that's it. As we saw here in the boundaries and the life cycle and the workers, in general, you don't need to go too low level. Just lean on the abstractions that are given to you. So the Gen server, but if you're using Phoenix, use Phoenix. If you need pooling, there are libraries for that, like use Poolboy. Just don't do them manually. A few more tips. We mentioned it, but for persistence, so we've built all of that. Of course, at some point you need the persistence, so you will build your ecto schemas. It's fine to have an ecto schema and your data structure, and they look almost similar, but they are not the same thing. Like your data structure is really your model that you're working with. The ecto schema is probably going to look very similar, maybe not. Maybe it will have some things that are concerns for the database and for persistence and for performances, and you will do a mapping. It has a cost. The cost is the you now have two distinct models and you have that decoupling, but it gives you a lot of flexibility. So I'm not saying that you should do it all the time, and sometimes it's totally fine to just code it directly with an ecto schema connected. Like if you're mostly exposing a CRUD API, so your API is basically update your database, yeah, you don't need to have that. But the moment you start having like involved pure logic, like business rules, it pays off to actually make this distinction. Oh, and yeah, I learned that you could actually put functions in the config that I didn't know before that, but you can do that. So you could imagine having the actual record function that is persisting to the database in prod, but in dev to have something in memory, or for test to have something in memory by default. And so the code doesn't change. You always call the persist function, but in your test, you know that it's not going to actually persist to a database, so you don't really need to start a database when you run your test. A database, but it could actually be more handy when you're dealing with a third-party service that you need to integrate with, like a payment system, and you cannot call them in test. Sometimes you have that. Knowing that you can do that is really handy, because you don't have to put that logic in the code. You just abstract away this thing. So there you have it. Yeah, I'm wrapping up. I took a bit more time than I thought, but we covered a few questions. I just want to mention that it's a great book. I would recommend reading it. If you live at least in Quebec, but check out with your country or city, you may have it in your library. If you live in Quebec, or if you are in Quebec, you can go to the BANQ, which is la Bibliothèque des Archives Nationales du Québec. Wait, je crois que c'est ça. I think it's this. So you can create an account for free when you live here. You just need to prove that you live in Quebec and in the province. And with that account, you can go on their catalog online, and they have a partnership with O'Reilly. So not only you have this book that you can read for free, but you have many other books, like you have Elixir in Action and a lot of things. I'm going through a lot of books like that. It's really nice. So that's my final tip. And thank you very much. Nurul, you had a question.
Yeah, I was actually going to ask you about the final slide that you covered before if you could go back, the one before that. Actually, yes. So you were talking about like to have a separate, I I guess, core model from the ecto schema. So does that mean like there would be some conversions necessary, like with data transfer objects, let's say, or stuff like that? And I would probably have to do that in the controllers before I, like, let's say I call the change set and then I do the conversion, do the model stuff, and then reconvert it and put it in the database, something like that? Or
it's yes, you will have to. That's the trade-off I mentioned. So that's why I'm not saying you should do that all the time. It's probably not the case, but you need to do that mapping back and forth.
Yeah.
Two things. First is, at least at the beginning, you probably have a very similar schema, so the mapping will actually be seamless. But if you need to do some more mapping, I would put these functions like from the ecto schema or to the ecto schema. I will put this function next to your ecto schema. Why? Because the core data structure, it should not know about the ecto schema. It doesn't know that it's being persisted in like using the ecto or whatever. But the ecto schema, it knows that, okay, I am persisting that model from here.
Right.
So you will put the mapper next to it and depend on your core structure and just translate, okay, what does it mean in one way or the other?
Okay, got it.
So the idea is that if you like, it should be at the end. You should have like a persist function from your. I don't know if you have a database layer or whatever. Wherever you put your ecto stuff, you have a model. In general, people do that in their what they call their model, but it's going to be like the persistent model that gives you the persistence API, kind of like update, read, whatever. And that will abstract away the conversions, for example. It will just accept the core data structure that you work with in the rest of your application. And at this point, it will do the change set, the validations, and all that. And it's totally fine. Like you will need also to use that change set in your like if you are doing live views or regular controllers. Of course, you will show an error message. Like this does not change anything about it. The only difference is what you when you delegate the work, like to compute something, you do not pass the ecto schema down to the functions. You pass your regular model. Now, it's working very well in other languages because that's basically what you do when you do the onion architecture or the hexagonal architecture. This is the spirit. I have never tried to apply it in production with Elixir, so maybe something to experiment.
Understood. I think it makes more sense too, because in Ecto, sometimes you have the timestamp, like in the schema, that you don't necessarily need in the, how do you call it, like in the model.
Yeah, that's that. Yeah. Sometimes you have things that are just needed for the database, and sometimes for performance reasons, and it's fine. But I found myself, maybe not with Elixir in particular, but on other projects that were involved, like real projects, that it's annoying because things are coupled. So it was fast, but now we have a problem that we want to change some part of it, like the API, for example, and it implies changing the database, or we need to go through an expensive decoupling operation. So it's easier to, when you know it's going to be like that, it's easier to start with this because it's always harder to cut later when you need to.
Oh, no, makes sense. Thanks.
You're welcome. Do you have any other questions or something you'd like me to cover? All right, no. So I'm gonna put gonna end the recording, and everything will be available on the Discord. Let me go back. Exit this presentation. Okay, stop here.